Question 1. When assessing the maturity of an organization's energy management system during an ISO 50001, 2018 audit, what specific auditor competency, developed through specialized training, is most critical for verifying the effectiveness of operational controls related to significant energy uses, SU, and the integration of energy performance indicators, NPI? Option A. Capacity to conduct a thorough review of all documented energy policies and procedures to ensure alignment with ISO 50001, 2018 requirements. Option B. The skill to quantify the financial savings achieved through implemented energy-saving projects and report these to top management. Option C. The ability to evaluate the systematic process of identifying SEUs, establishing relevant variables, setting energy baselines, and verifying the effectiveness of corrective actions for performance deviations. Option D. The proficiency in identifying potential energy-saving opportunities based on general industry best practices, irrespective of the organization's specific operational context. Correct answer is C. The ability to evaluate the systematic process of identifying SEUs, establishing relevant variables, setting energy baselines, and verifying the effectiveness of corrective actions for performance deviations. Explanation. The effectiveness of an energy management system, NMS, audit, particularly in the context of ISO 50001, 2018, hinges on the auditor's ability to discern the genuine implementation of energy review and operational controls rather than superficial adherence. An auditor's training must equip them to probe beyond documented procedures and assess the practical application of energy-saving measures and the integration of energy performance indicators, NPI, into daily operations. This involves evaluating whether the organization has established relevant variables, identified significant energy uses, SU, and set appropriate energy baselines and targets that are actively monitored and adjusted. Key aspect of advanced auditor training involves understanding how to verify the effectiveness of corrective actions for nonconformities identified in previous audits or through internal reviews. This includes ensuring that the root causes of energy performance deviations are addressed and that preventive measures are robust. Furthermore, the training should emphasize the auditor's role in assessing the organization's commitment to continual improvement of energy performance, including the systematic review of energy data, the implementation of action plans, and the incorporation of lessons learned into future planning. The auditor must be able to distinguish between a system that merely lists energy-saving actions and one that demonstrates a dynamic process of optimization driven by performance data and management commitment. Therefore, training focused on assessing the integration of NPIs, the systematic approach to identifying and managing SEUs, and the verification of corrective actions for performance improvements is crucial for a lead implementer auditor. Question 2. A multinational manufacturing company, Ether Dynamics, is implementing its ISO 50001, 2018 Certified Energy Management System. The energy management team has identified various internal and external interested parties, including production line supervisors, the Environmental Compliance Department, local community representatives concerned about emissions, and the procurement division responsible for purchasing new equipment. Considering the diverse interests and potential influence of these groups on energy performance, which approach would be most effective for the ISO 50001, 2018 lead implementer to foster meaningful engagement and ensure their support for the NMS? Option A. Rely primarily on the organization's existing corporate social responsibility reports to communicate energy performance updates to all interested parties, assuming their interests are adequately covered. Option B. Prioritize engagement with only those stakeholders directly involved in energy consumption, such as the production line supervisors, to streamline communication and resource allocation. Option C. Develop tailored communication plans for each stakeholder group, focusing on their specific interests and potential impact on energy performance, and establish regular feedback loops to address concerns and incorporate suggestions into the NMS. Option D. Conduct a single, comprehensive workshop for all identified stakeholders to present the overarching energy management strategy and solicit general feedback on the proposed initiatives. Correct answer is C. Develop tailored communication plans for each stakeholder group, focusing on their specific interests and potential impact on energy performance, and establish regular feedback loops to address concerns and incorporate suggestions into the NMS. Explanation. The core of effective stakeholder engagement within an ISO 50001-2018 framework lies in understanding their interests and influence to foster support and collaboration for energy management initiatives. Clause 4. 2. Understanding the needs and expectations of interested parties mandates the identification of relevant stakeholders and their requirements pertaining to energy performance. For a lead implementer, this means moving beyond mere identification to strategic engagement, analyzing the potential impact of energy management on different groups, such as operational staff, finance departments, regulatory bodies, and local communities, is crucial. The effectiveness of engagement is measured by the degree to which these stakeholders' perspectives are considered and integrated into the energy management system, NMS, leading to improved energy performance and buy-in. A proactive approach, involving regular communication, feedback mechanisms, and tailored information sharing, ensures that their concerns are addressed and their contributions are leveraged. This fosters a more robust and sustainable NMS that is aligned with both organizational objectives and external expectations. For instance, engaging the finance department early on about the potential cost savings from energy efficiency projects can secure their support and facilitate budget allocation, a critical factor for successful implementation. Similarly, understanding the operational constraints of plant managers ensures that proposed energy-saving measures are practical and achievable. Question 3. A manufacturing firm, Ether Dynamics, is implementing an ISO 50001-2018 energy management system. The lead implementer has identified that the maintenance team, responsible for the upkeep of critical energy-consuming machinery, lacks formal training in energy-efficient operational practices and diagnostic techniques for identifying energy waste. While the team possesses extensive mechanical expertise, their understanding of energy performance indicators, NPI, and the impact of their maintenance decisions on overall energy consumption is limited. The organization operates under national energy efficiency regulations that mandate reporting on specific energy-intensive equipment performance. Which approach would be most effective for the lead implementer to ensure the maintenance team meets the competence and awareness requirements of ISO 50001-2018, considering the regulatory context? Option A. Rely on the team's existing mechanical experience and provide only a brief overview of the organization's energy policy and objectives during a general staff meeting. Option B. Outsource all maintenance tasks related to energy-intensive equipment to external specialists who are certified in energy management, thereby mitigating the need for internal team training. Option C. Implement a performance review system that penalizes maintenance personnel for any identified energy inefficiencies, without providing prior training or awareness on how to prevent them. Option D. Develop and deliver a targeted training program that covers ISO 50001-2018 requirements related to their roles, energy-efficient maintenance procedures, the use of diagnostic tools for energy waste identification, and the significance of their contribution to NPIs and regulatory compliance. The correct answer is D. Develop and deliver a targeted training program that covers ISO 50001-2018 requirements related to their roles, energy-efficient maintenance procedures, the use of diagnostic tools for energy waste identification, and the significance of their contribution to NPIs and regulatory compliance. Explanation. ISO 50001-2018 Clause 7. 2. Competence mandates that an organization shall determine the necessary competence for personnel that affects its energy performance and whose work affects its energy performance. This includes individuals involved in energy review, establishing energy baselines, energy performance indicators, operational controls, and the energy management system itself. The standard requires that personnel be competent on the basis of appropriate education, training, or experience. Furthermore, Clause 7.3 Awareness requires that personnel be aware of the energy policy, relevant energy objectives and targets, their contribution to the effectiveness of the energy management system, including the benefits of improved energy performance, and the implications of not conforming with the energy management system requirements. The lead implementer's role is to ensure that these requirements are met through systematic identification of competence needs, provision of appropriate training or other actions to satisfy these needs, and verification of the effectiveness of these actions. This includes ensuring that individuals understand not only the technical aspects of energy management, but also their role in achieving the organization's energy objectives and the broader implications for sustainability and compliance. The process involves assessing current competence, identifying gaps, and implementing a plan to bridge those gaps, ensuring that the energy management system is effectively managed and continuously improved by knowledgeable and aware personnel. Question 4. A manufacturing plant operating under an ISO 50001-2018 certified energy management system has consistently exceeded its energy performance targets for the past 3 quarters. However, an internal audit has identified that the procedures for addressing significant energy-consuming equipment, CES, performance deviations are not consistently followed. Specifically, the root cause analysis for a recent minor increase in steam consumption for a particular process was not thoroughly documented, and the subsequent corrective actions were based on assumptions rather than verified findings. What is the most appropriate strategic approach for the energy management team to ensure the continual improvement of the energy management system in light of this situation, considering the principles of ISO 50001-2018? Option A. Focus solely on achieving further energy savings through new technology investments, as the plant is already exceeding its performance targets, and address the procedural issues only if they directly lead to a significant energy performance shortfall in the future. Option B. Immediately implement a new, more complex software system for energy data logging to improve the accuracy of future performance monitoring, assuming the current system is the root cause of the documentation gaps. Option C. Retrain all personnel involved in energy management on the basic principles of ISO 50001-2018, with a particular emphasis on the importance of documentation and reporting, without addressing the specific procedural deficiencies identified. Option D. Conduct a comprehensive review of the entire energy performance monitoring and review process, focusing on the documentation requirements for CES deviations, and ensuring that root cause analysis is robust and evidence-based before implementing corrective actions. The correct answer is D. Conduct a comprehensive review of the entire energy performance monitoring and review process, focusing on the documentation requirements for CES deviations, and ensuring that root cause analysis is robust and evidence-based before implementing corrective actions. Explanation. The core of continual improvement in ISO 50001-2018 lies in systematically reviewing performance, identifying deviation, and implementing corrective actions. Clause 10. 1. Nonconformity and corrective action mandates that an organization shall take action to eliminate the causes of nonconformities to prevent recurrence. This involves analyzing the root cause of any energy performance deviation or nonconformance with the energy management system, NMS. The process typically includes investigating the issue, determining the root cause, evaluating the need for action to prevent recurrence, implementing the necessary actions, and reviewing their effectiveness. For instance, if a facility experiences an unexpected increase in electricity consumption during off-peak hours, the NMS lead implementer would guide the team to investigate why this deviation occurred. This investigation might reveal a faulty timer on a large HVAC unit, leading to it operating unnecessarily. The corrective action would involve repairing or replacing the timer. Subsequently, the effectiveness of this repair would be monitored to ensure the anomaly does not reoccur, thereby demonstrating the continual improvement cycle. The emphasis is on a structured, data-driven approach to enhance energy performance and the NMS itself. Question 5. Consider a medium-sized manufacturing facility that has recently committed to implementing an ISO 50001-2018 compliant energy management system. The organization's top management has appointed a senior engineer, Mr. Aris Thorne, as the energy manager. Mr. Thorne is tasked with developing the energy management system, but he has limited direct authority over operational departments such as production, maintenance, and facilities. To effectively drive energy performance improvements and ensure the system's integration, what is the most critical initial step Mr. Thorne must take regarding the definition of roles, responsibilities, and authorities within the context of ISO 50001-2018? Option A. Prepare a proposal for additional headcount to create a full-time energy management department, thereby consolidating all energy-related responsibilities under a single, empowered unit. Option B. Immediately initiate a comprehensive energy audit to identify all significant energy uses and baseline energy consumption patterns before defining any roles. Option C. Develop a detailed organizational chart for the energy management system, assigning a dedicated energy coordinator for every 50 employees, regardless of their current roles. Option D. Secure formal documented commitment from top management that clearly delegates necessary authority to Mr. Thorne and designates specific responsible individuals within each operational department for energy-related tasks. The correct answer is D. Secure formal documented commitment from top management that clearly delegates necessary authority to Mr. Thorne and designates specific responsible individuals within each operational department for energy-related tasks. Explanation: the fundamental principle of ISO 50001/2018 regarding roles, responsibilities, and authorities is to ensure that all personnel understand their contribution to the energy management system's effectiveness and the organization's energy performance. Clause 5.3, competence, training, and awareness, and Clause 7.1.2, competence, along with the general requirements for management responsibility outlined in Clause 5.1, leadership and commitment, and 5.3, organizational roles, responsibilities, and authorities, collectively mandate this. A lead implementer must ensure that these roles are clearly defined and communicated. This involves identifying who is accountable for specific energy management activities, who has the authority to make decisions regarding energy use and improvements, and who is responsible for implementing policies and procedures. The effectiveness of the energy management system is directly linked to how well these responsibilities are understood and executed at all levels. This includes ensuring that individuals have the necessary competence and that awareness is fostered throughout the organization regarding the energy policy, significant energy uses, and their individual contributions to achieving energy objectives and targets. The process is iterative, requiring continuous review and adjustment as the energy management system matures and organizational structures evolve. It is not merely about assigning tasks, but about embedding energy management into the organizational culture and operational practices. Question 6. Considering a large manufacturing facility with a highly intricate, multi-stage production line, where numerous environmental and operational variables significantly influence energy consumption, and the objective is to pinpoint specific, actionable energy-saving opportunities with precise quantification of potential benefits. Which approach to energy audit methodology planning would best align with ISO 50001/2018 requirements for establishing operational controls for significant energy uses? Option A. A qualitative assessment based on expert interviews and visual inspections of major equipment. Option B. A top-down, holistic review primarily relying on aggregated energy bills and overall facility performance indicators. Option C. A detailed, bottom-up analysis focusing on granular data collection and process stage-specific performance evaluation. Option D. A comparative analysis benchmarking against industry averages without in-depth process investigation. Correct answer is C. A detailed bottom-up analysis focusing on granular data collection and process stage-specific performance evaluation. Explanation: the question pertains to the crucial initial phase of energy audit planning within an ISO 50001/2018 framework, specifically focusing on the selection of appropriate audit methodologies. ISO 50001/2018 Clause 6.3.2 mandates the establishment of operational controls for significant energy uses (SEU). The planning of an energy audit, as detailed in Annex A. 5, requires considering the scope and boundaries of the audit, which directly influences the choice of methodology. A comprehensive energy audit for an SEU must gather detailed information about energy consumption, operational parameters, and influencing factors. When an organization has a complex production process with numerous variables affecting energy consumption, and the primary goal is to identify specific areas for improvement and quantify potential savings, a detailed, bottom-up approach is most effective. This involves dissecting the process into its constituent parts, collecting granular data for each, and analyzing the energy performance at each stage. This methodical breakdown allows for a thorough understanding of energy flows and the identification of inefficiencies that might be masked in a more aggregated approach. The energy audit plan should outline the specific data to be collected, the methods for collection, e.g., direct measurement, review of historical data, interviews, and the analytical techniques to be employed. For a complex process, this detailed approach ensures that all relevant factors contributing to energy consumption are investigated, leading to more accurate identification of improvement opportunities and robust baseline establishment. Question 7. A manufacturing firm, Astro Plastics, has completed its initial energy review as per ISO 50001, 2018. The review identified that their injection molding machines are a significant energy user, with energy consumption heavily influenced by ambient temperature and the batch size of plastic pellets. They have also identified potential energy-saving measures, such as upgrading to more energy-efficient motors and optimizing machine operating parameters. As the lead implementer, how should the findings of this energy review be most effectively integrated into the subsequent stages of the energy management system to ensure continual improvement? Option A. Focus solely on the technical aspects of the energy-saving measures, such as motor efficiency, and defer the consideration of operational parameter optimization until a later phase. Option B. Immediately proceed with implementing all identified energy-saving measures without further analysis, assuming they will all yield significant improvements. Option C. Document the energy review findings in a report and file it, awaiting the next scheduled annual review to re-evaluate the data. Option D. Use the identified significant energy uses, their influencing factors, and potential savings opportunities to establish specific, measurable, achievable, relevant, and time-bound, SMART, energy objectives and associated energy performance indicators, NPI. The correct answer is D. Use the identified significant energy uses, their influencing factors, and potential savings opportunities to establish specific, measurable, achievable, relevant, and time-bound, SMART, energy objectives and associated energy performance indicators, NPI. Explanation. The energy review process within ISO 50001-2018 is a cornerstone for understanding an organization's energy consumption and identifying opportunities for improvement. It involves analyzing energy data, identifying significant energy uses, SU, and establishing energy baselines and performance indicators, NPI. Clause 6.3 of ISO 50001, 2018 specifically mandates the energy review. The review must consider past and present energy performance and the factors influencing it, including the outcomes of previous energy reviews. It also requires identifying SEUs and the relevant variable and fixed factors affecting them. Furthermore, it necessitates the identification of opportunities for improving energy performance and for improving the energy management system itself. The review should also consider available technologies for improving energy performance and the economic energy considerations. When conducting an energy review, a lead implementer must ensure that the process is iterative and that the findings inform the development and implementation of energy objectives, targets, and action plans. The review is not merely a data collection exercise. It's a strategic analysis to drive energy efficiency and performance. The question tests the understanding of the iterative nature of the energy review and its direct link to the establishment of objectives and targets, which is a core requirement for demonstrating continual improvement in energy performance. The energy review informs what is achievable and what needs to be prioritized, directly feeding into the planning process. Question 8. When establishing the criteria for identifying significant energy uses, SU, within an organization adhering to ISO 50001, 2018, what is the primary overarching principle that guides the selection process, ensuring that the energy uses identified are truly impactful on the organization's energy performance? Option A. Energy uses that have undergone recent technological upgrades, assuming these automatically make them significant regardless of their overall contribution to energy performance. Option B. Only those energy uses that are explicitly mentioned in national energy efficiency regulations or standards applicable to the organization's sector. Option C. A comprehensive evaluation considering multiple factors including energy consumption volume, energy cost, operational impact, and potential for energy performance improvement, as determined by the organization. Option D. The energy uses that demonstrate the highest absolute energy consumption and cost, irrespective of operational criticality or improvement potential. The correct answer is D. The energy uses that demonstrate the highest absolute energy consumption and cost, irrespective of operational criticality or improvement potential. Explanation. The identification of significant energy uses (SU) is a foundational step in establishing an effective energy management system (NMS) under ISO 50001-2018. Clause 4.2.1a mandates that the organization shall determine external and internal issues that are relevant to its purpose and affect its ability to achieve the intended outcome (S) of its NMS. Clause 6.1.2a requires that the organization shall determine its energy uses and consumption. Clause 6.1.2b states that the organization shall determine which energy uses have or can have significant impact on its energy performance. The process of identifying SEUs involves analyzing energy consumption data, identifying energy-consuming equipment and processes, and evaluating their contribution to overall energy use and cost. While quantitative data is crucial, qualitative factors also play a role. For instance, a process that is critical to the organization's operations, even if its energy consumption is not the absolute highest, might be considered significant due to its operational importance or potential for improvement. The standard emphasizes that SEUs should be reviewed at planned intervals and, when necessary, revised. This iterative process ensures that the NMS remains relevant and effective in managing energy performance. The focus is on identifying those energy uses that have the most substantial impact on the organization's energy performance, allowing for targeted improvement efforts. The definition of significant is context-dependent and should be established by the organization itself based on its specific circumstances, objectives, and criteria. This includes considering factors like energy consumption volume, energy cost, potential for improvement, and operational criticality. Question 9. Considering the foundational principles of ISO 50001-2018 for establishing and maintaining an effective energy management system, which entity bears the ultimate responsibility for ensuring the consistent availability of adequate human, financial, and technological resources to support the system's operation and continual improvement initiatives? Option A, the Energy Management Team. Option B, Top Management. Option C, External Energy Consultants. Option D, the Designated Energy Manager. Correct answer is B, Top Management. Explanation: the successful implementation and ongoing improvement of an energy management system, NMS, under ISO 50001-2018 necessitates a comprehensive understanding of the resources required. Clause 5.1. One of the standard emphasizes that top management shall demonstrate leadership and commitment by ensuring the availability of resources necessary for the establishment, implementation, maintenance, and continual improvement of the NMS. These resources encompass human resources, financial resources, and technological resources. Human resources include competent personnel with the necessary skills, training, and awareness to effectively manage energy. Financial resources involve the allocation of budget for energy audits, energy performance improvement projects, monitoring equipment, and training. Technological resources refer to the availability of appropriate measurement and monitoring equipment, energy-efficient technologies, and information systems for data analysis and reporting. A lead implementer must be able to identify, secure, and manage these resources effectively to achieve the organization's energy objectives and targets. The question probes the understanding of the primary responsibility for ensuring the availability of these critical resources within the framework of ISO 50001-2018. Top management's commitment, as outlined in Clause 5.1, is fundamental to providing the necessary support for the NMS. Therefore, the ultimate accountability for ensuring the availability of human, financial, and technological resources rests with top management. Question 10. When developing an energy baseline for a new manufacturing facility that operates on a variable shift schedule and produces multiple product lines with differing energy intensities, what is the most critical factor for the ISO 50001 lead implementer to ensure for the baseline's representativeness and future comparability? Option A. Setting an aggressive initial energy performance target that assumes significant future efficiency gains, regardless of the actual baseline data. Option B. Reliance on historical energy consumption data from a similar but not identical facility to establish the initial baseline without extensive site-specific data collection. Option C. Selection of a single primary operational metric, such as total production output, to simplify the baseline calculation and reporting process. Option D. Rigorous identification and quantification of all significant variables influencing energy consumption, including production volume per product line, operational hours per shift, and ambient temperature, to enable accurate normalization. The correct answer is D. Rigorous identification and quantification of all significant variables influencing energy consumption, including production volume per product line, operational hours per shift, and ambient temperature, to enable accurate normalization. Explanation: establishing a robust energy baseline is a fundamental step in implementing an ISO 50001 energy management system. The baseline serves as a reference point against which energy performance improvements are measured. According to ISO 50001-2018, the organization must establish an energy baseline or baselines that are representative of the operational and commercial conditions under which energy performance is to be measured. This involves identifying relevant variables that influence energy consumption, such as production volume, operating hours, climate conditions, and occupancy levels. These variables are then used to normalize energy consumption, allowing for fair comparisons over time, even when operational conditions change. The process requires careful data collection, validation, and analysis to ensure the baseline accurately reflects the organization's energy usage patterns. The baseline should be documented and reviewed periodically, especially when significant changes occur in the organization's operations or the identified variables. Selection of appropriate variables for normalization is crucial for demonstrating meaningful energy performance improvements and achieving the objectives of the energy management system. For instance, if a manufacturing plant increases its production output, a baseline normalized by production volume will correctly show whether energy consumption per unit of output has decreased, even if total energy consumption has risen due to higher activity. Question 11. Consider a manufacturing facility implementing an ISO 50001-2018 energy management system. During the energy review phase, the team identifies that the compressed air system, a significant energy user, exhibits high leakage rates and inefficient operation due to outdated regulators. They also note that local environmental regulations are being revised to include stricter emission standards for industrial processes. Which of the following approaches best aligns with the ISO 50001-2018 requirement for identifying and prioritizing energy-saving opportunities, ensuring both technical and regulatory considerations are addressed? Option A. Immediately implement a comprehensive leak detection program across all plant utilities and schedule a review of all pneumatic equipment for potential replacement, without initially quantifying the specific energy savings or considering the regulatory impact. Option B. Document the high leakage rates in the compressed air system as a known issue and await further directives from management on potential improvements, while separately monitoring the progress of the revised environmental regulations. Option C. Prioritize addressing the compressed air system inefficiencies by quantifying the energy savings from leak repair and regulator upgrades, calculating the return on investment for these measures, and assessing their impact on meeting the revised environmental emission standards. Option D. Focus solely on upgrading the compressed air system regulators to the latest energy-efficient models, assuming this will automatically lead to compliance with future emission standards and significant energy savings without detailed analysis. The correct answer is C. Prioritize addressing the compressed air system inefficiencies by quantifying the energy savings from leak repair and regulator upgrades, calculating the return on investment for these measures, and assessing their impact on meeting the revised environmental emission standards. Explanation: the core of identifying energy-saving opportunities within an ISO 50001-2018 framework involves a systematic approach that moves beyond superficial observations. Clause 6.1, 2, Energy Review, and Clause 6.3, Planning of Actions, are pivotal. An energy review requires identifying significant energy uses (SU) and their associated energy baselines and energy performance indicators (NPI). Opportunities for improving energy performance are then derived from this review, considering technical feasibility, economic viability, and operational impact. While initial identification might involve simple walkthroughs, a comprehensive approach necessitates detailed analysis of energy consumption data, equipment performance, and operational practices. The process involves evaluating the potential impact of identified opportunities on energy performance, considering factors like capital investment, payback periods, and potential for operational disruption. Furthermore, regulatory requirements, such as those mandated by national energy efficiency directives or local emission standards, must be integrated into the evaluation process, as they can influence the prioritization and feasibility of certain opportunities. The development of action plans for implementing these opportunities, as outlined in Clause 6.3, is a critical step that translates potential savings into realized improvements. This planning phase must address resource allocation, responsibilities, timelines, and the establishment of monitoring mechanisms to track progress and verify outcomes. The continuous improvement cycle, Plan Do Check Act, underpins the entire process, ensuring that energy management is an ongoing endeavor. Therefore, the most effective strategy for identifying and prioritizing opportunities involves a multifaceted approach that combines data analysis, technical assessment, economic evaluation, and regulatory compliance, all aligned with the organization's energy policy and objectives. Question 12. During the establishment of an energy baseline for a large industrial facility, an energy manager identifies that electricity consumption in the primary processing unit is significantly influenced by both the total output of finished goods and the ambient external temperature. The organization operates under a regional mandate that requires energy performance to be reported against a baseline established using statistically sound methods. Considering significant variables, which of the following approaches best aligns with the requirements of ISO 50001-2018 for establishing this energy baseline? Option A. Develop a regression model that quantifies the relationship between electricity consumption, dependent variable, and both production output and ambient temperature, independent variables, over a defined representative operational period. Option B. Calculate the average monthly electricity consumption over the past 3 years and use this as the baseline, assuming that production and temperature variations are negligible. Option C. Implement a dynamic baseline that adjusts based on daily production schedules, ignoring external environmental factors to maintain consistency in measurement. Option D. Focus solely on the total annual electricity consumption for the past year as the baseline, without considering any specific operational drivers or their impact. The correct answer is A. Develop a regression model that quantifies the relationship between electricity consumption, dependent variable, and both production output and ambient temperature, independent variables, over a defined representative operational period. Explanation. The core principle behind establishing a baseline in ISO 50001-2018 is to create a representative snapshot of energy consumption and performance indicators under specific operating conditions. This baseline serves as a reference point for evaluating future energy performance improvements. To establish a robust baseline, it's crucial to select relevant energy performance indicators, NPI, that accurately reflect the relationship between energy use and the key variables influencing it. These variables, known as significant energy use drivers or contextual factors, must be identified through the organization's energy review process. For example, in a manufacturing plant, production volume is a primary driver of energy consumption. The baseline period should be representative of typical operating conditions, avoiding anomalies or extreme events that could skew the data. Statistical analysis is then applied to the data collected during this period to determine the relationship between energy consumption and the identified drivers. This analysis helps in understanding how changes in these drivers impact energy use. The resulting baseline, often expressed as a model or equation, quantifies the expected energy consumption for a given level of the driver. This allows for the objective assessment of energy performance over time by comparing actual energy consumption against the baseline, adjusted for variations in the drivers. The process involves identifying suitable NPIs, collecting data for a representative period, identifying and quantifying the influence of key variables, and establishing a baseline model. Question 13. Consider a manufacturing facility that has completed its initial energy review as per ISO 50001-2018. The review identified that the compressed air system and the main process heating furnace are significant energy uses. It also established a baseline for specific energy consumption, SEC, for both these uses. The organization is now looking to set its first set of energy objectives and targets. What is the most direct and crucial outcome of the completed energy review that will enable the effective establishment of these objectives and targets? Option A. A comprehensive list of all energy-consuming equipment, irrespective of its contribution to overall energy consumption. Option B, a detailed historical analysis of all energy bills from the past 5 years, regardless of their relevance to significant energy uses. Option C, the finalization of energy-saving projects that have already been implemented and demonstrated savings. Option D, the establishment of a clear baseline for energy performance indicators and the identification of significant energy uses. The correct answer is D, the establishment of a clear baseline for energy performance indicators and the identification of significant energy uses. Explanation: the energy review process within ISO 50001/2018 requires a comprehensive understanding of an organization's energy consumption and performance. This includes identifying significant energy uses, SEU, and establishing a baseline for energy performance indicators, NPI. When evaluating the effectiveness of the energy review, a lead implementer must consider how well the review has facilitated the identification of opportunities for improving energy performance, and how it has informed the establishment of energy objectives and targets. The review's ability to provide a clear picture of energy consumption patterns, the impact of operational changes, and potential areas for energy-saving measures is paramount. An effective energy review should lead directly to actionable insights that can be translated into concrete improvements. Therefore, the most direct outcome of a well-executed energy review, in terms of its contribution to the overall energy management system, is the establishment of a clear baseline for energy performance indicators and the identification of significant energy uses, which then directly informs the setting of relevant energy objectives and targets. This forms the foundation for subsequent planning and action. Question 14. Consider an industrial facility that has consistently failed to meet its energy reduction targets, exhibiting significant energy waste and a general lack of awareness among its workforce regarding energy efficiency practices. As the lead implementer for ISO 50001/2018, what fundamental step must be prioritized to establish an effective communication strategy for improving energy performance and engaging relevant stakeholders? Option A, conduct a comprehensive analysis of historical energy consumption data to identify significant energy uses and establish baseline energy performance indicators before initiating broader stakeholder communication. Option B, schedule a series of meetings with senior management to present potential energy-saving technologies, assuming they will dictate the communication priorities. Option C, develop a detailed communication plan outlining all potential internal and external communication channels, without first defining the core message based on energy performance data. Option D, immediately launch a company-wide awareness campaign through posters and emails, highlighting the importance of energy saving without first identifying specific areas of improvement. The correct answer is A, conduct a comprehensive analysis of historical energy consumption data to identify significant energy uses and establish baseline energy performance indicators before initiating broader stakeholder communication. Explanation: the effectiveness of an energy management system, NMS, relies heavily on clear and consistent communication regarding energy performance objectives and actions. ISO 50001/2018 Clause 7. 4. Communication mandates that an organization shall determine the need for the internal and external communications relevant to the energy management system, including what, when, with whom, how, and who will communicate. The question focuses on the most critical aspect of communication for an NMS lead implementer. When addressing an organization that has historically poor energy performance and lacks a structured approach, this requires establishing a baseline understanding of current energy use and identifying significant energy uses, SEU, before engaging stakeholders. Without this foundational understanding, any communication regarding improvements or targets would be speculative and lack credibility. Therefore, the initial step for the lead implementer must be to establish the necessary information base to inform all subsequent communications. This involves data collection and analysis to identify SEUs and establish baseline energy performance indicators, NPI, and energy baselines. This forms the bedrock for all communication, ensuring that discussions about energy performance are grounded in factual data and that improvement opportunities are clearly identified. The subsequent communication strategy will then be built upon this understanding, tailored to different stakeholder groups to foster engagement and drive action towards achieving energy objectives. Question 15. During the review of an established ISO 50001, 2018 energy management system at a large manufacturing facility, the energy team observes a consistent upward trend in the specific energy consumption for a key production line, despite no significant changes in production volume or product mix. The team has meticulously verified the accuracy of the metering equipment and the integrity of the data collection process. What is the most critical next step for the energy team to take in their analysis to effectively address this performance deviation? Option A. Propose an immediate upgrade to more advanced energy monitoring hardware to capture finer granular data for future analysis. Option B. Document the observed trend as a deviation and schedule a general review of the energy management system's overall effectiveness in the next management review meeting. Option C. Immediately initiate a review of all energy performance indicators across the entire facility to ascertain if this is an isolated incident or a systemic issue. Option D. Investigate potential degradation in equipment efficiency or identify unforeseen operational factors impacting energy use on that specific production line. The correct answer is D. Investigate potential degradation in equipment efficiency or identify unforeseen operational factors impacting energy use on that specific production line. Explanation: the core principle behind establishing and maintaining an energy management system, NMS, according to ISO 50001-2018, particularly concerning monitoring, measurement, and analysis, is to gain actionable insights into energy performance. This involves not just collecting data, but understanding its context and implications for energy objectives and targets. When analyzing energy performance, it is crucial to identify significant energy uses, SU, and their corresponding energy performance indicators, NPI. The analysis should also consider the impact of operational and performance changes on these SEUs and NPIs. Furthermore, the standard mandates that organizations establish a process for monitoring, measuring, and analyzing their energy performance, and the NMS. This process must be documented and regularly reviewed to ensure its effectiveness. The analysis should lead to informed decisions regarding operational improvements, energy-saving opportunities, and adjustments to the NMS itself. The effectiveness of the NMS is directly linked to the quality and depth of this analysis, which underpins continual improvement. Therefore, a comprehensive analysis, encompassing trends, deviations, and the impact of relevant factors, is fundamental to achieving the organization's energy policy and objectives. Question 16. When developing a comprehensive energy awareness program for a large manufacturing facility with a diverse workforce, including machine operators, maintenance technicians, and administrative staff, what is the most critical factor for a lead implementer to consider to ensure the program's effectiveness in driving behavioral change and supporting the organization's energy performance objectives as per ISO 50001-2018? Option A. Primarily focusing on the financial savings achieved through energy efficiency measures to motivate employees. Option B. Emphasizing the legal and regulatory requirements related to energy consumption without linking it to daily operational impacts. Option C. Implementing a single, standardized awareness module for all personnel to ensure consistency and ease of administration. Option D. Tailoring the content and delivery methods to the specific roles, responsibilities, and existing knowledge levels of different employee groups. The correct answer is D. Tailoring the content and delivery methods to the specific roles, responsibilities, and existing knowledge levels of different employee groups. Explanation: ISO 50001-2018 specifically in Clause 7. 2. Competence in Clause 7. 3. Awareness mandates that an organization establish, implement, and maintain processes to ensure personnel are competent and aware of the energy policy, relevant energy objectives, targets, and the importance of conforming to the energy management system. Awareness programs should communicate the significance of conforming to the energy management system requirements, the benefits of improved energy performance, and the implications of not conforming. The effectiveness of these programs is crucial for driving behavioral change and achieving energy performance improvements. When designing an awareness program for a diverse workforce, including operational staff, management, and support functions, a lead implementer must consider the varied levels of technical understanding and job roles. The program should be tailored to resonate with each group, highlighting how their individual actions contribute to the overall energy performance objectives. For operational staff, practical demonstrations and on-the-job training might be most effective, focusing on specific energy-saving practices relevant to their tasks, such as proper equipment shutdown procedures or identifying energy waste. For management, the focus should be on the strategic and financial implications of energy performance, linking it to business objectives and regulatory compliance. A comprehensive awareness program fosters a culture of energy consciousness throughout the organization, which is a prerequisite for sustained energy performance improvements. The effectiveness of such a program is often evaluated through feedback mechanisms, observed changes in behavior, and ultimately, the achievement of energy objectives and targets. Question 17. When developing energy performance indicators, NPI, for manufacturing facility, that utilizes a complex, multi-stage process with varying production schedules and shifts, which of the following approaches best ensures the NPI accurately reflects changes in energy efficiency attributable to management system improvements, rather than fluctuations in operational output or external conditions? Option A. Establish an NPI based on energy consumed per kilowatt-hour generated by on-site renewable sources, as this directly links to the facility's overall energy self-sufficiency and operational efficiency. Option B. Create an NPI that tracks the percentage reduction in energy use compared to the previous year's baseline, without normalizing against any specific operational or external variable, to demonstrate year-on-year improvement. Option C. Select an NPI that normalizes energy consumption by the total number of operating hours for all machinery, acknowledging that shifts vary, and incorporate a factor for average daily ambient temperature to account for external influences. Option D. Develop an NPI that measures total energy consumed per unit of finished product, ensuring that the definition of a unit is consistent and clearly documented, and that the production volume is the primary normalization factor. The correct answer is C. Select an NPI that normalizes energy consumption by the total number of operating hours for all machinery, acknowledging that shifts vary, and incorporate a factor for average daily ambient temperature to account for external influences. Explanation: the development of energy performance indicators, NPI, under ISO 50001/2018 requires careful consideration of variables that influence energy performance. An NPI should quantify energy performance and relate it to a relevant variable, which could be a static factor or a dynamic one. Static variables do not change significantly over the period being measured, or are not directly influenced by energy-consuming activities in a way that requires normalization. Dynamic variables, on the other hand, are factors that directly impact energy consumption and can fluctuate, necessitating their inclusion to ensure a meaningful comparison of energy performance over time. The key is to identify variables that are statistically significant and have a causal relationship with energy use. When establishing NPIs, the standard emphasizes selecting variables that are appropriate for the specific energy use, measuring equipment, and operational factors. A robust NPI will allow for the tracking of improvements or deteriorations in energy performance, independent of changes in these relevant variables. For instance, energy consumed per unit of production is a common NPI where unit of production is a dynamic variable. However, if an organization seeks to track the energy performance of a building's HVAC system, factors like occupancy hours or the number of days the system is operational are crucial dynamic variables. Conversely, a static variable might be the geographical location of the facility, which influences ambient conditions, but is not typically normalized against in the NPI itself, unless the NPI is specifically designed to compare different locations. The intent is to isolate the impact of energy management actions. Question 18. A manufacturing facility has completed its initial energy review and identified several high-impact opportunities for energy reduction, including optimizing compressed air systems and upgrading lighting infrastructure. The management team is now tasked with allocating resources to implement these changes. Considering the requirements of ISO 50001/2018 for establishing and maintaining an energy management system, what is the most critical initial resource allocation to ensure the successful implementation of these identified energy-saving opportunities? Option A. Procuring advanced energy monitoring software to track the performance of the upgraded equipment and identify further anomalies. Option B. Investing in comprehensive training programs to enhance the competence of relevant personnel in operating and maintaining the optimized systems and new technologies. Option C. Establishing a dedicated internal energy management team with specific roles and responsibilities for overseeing all energy-related projects. Option D. Allocating budget for external consultants to validate the energy savings achieved and provide ongoing advisory services. The correct answer is B. Investing in comprehensive training programs to enhance the competence of relevant personnel in operating and maintaining the optimized systems and new technologies. Explanation. The scenario describes a situation where an organization has identified significant energy savings opportunities through a review of its operational procedures and equipment. The ISO 50001 standard, specifically Clause 7, 2 regarding competence and Clause 7, 3 regarding awareness, mandates that personnel involved in energy management activities must have the necessary skills and understanding. Furthermore, Clause 4, 1 on operational control requires the organization to establish, implement, maintain, and continually improve an energy management system, which includes managing energy use through planned operational controls. Clause 2 on energy action plans requires the establishment of objectives and targets for energy performance improvement and the implementation of plans to achieve them. To effectively implement these identified savings, the organization needs to allocate resources, which includes ensuring that personnel possess the requisite knowledge and skills to execute the planned actions and manage the energy performance improvements. This directly relates to ensuring competence and fostering awareness among relevant personnel for successful energy management system implementation and operation. The identified opportunities necessitate specific technical expertise and a thorough understanding of energy-efficient practices, which must be addressed through training and development. Therefore, the most critical resource allocation at this stage is focused on developing the competence of personnel involved in executing these energy-saving initiatives. Question 19. A manufacturing firm, Luminary Forge, has set an objective to reduce its overall electricity consumption by 15% within 2 years, supported by an energy performance indicator, NPI, tracking kWh per unit of output. During the development of their action plan, the energy management team identified several potential initiatives: upgrading to LED lighting, optimizing compressed air system efficiency, and implementing variable frequency drives, VFD, on large motors. Luminary Forge's legal department has also highlighted a new regional regulation mandating stricter controls on fugitive emissions from industrial processes, which indirectly impacts energy usage in the plant's ventilation systems. Which of the following approaches most comprehensively addresses the requirements for developing Luminary Forge's action plan according to ISO 50001, 2018, ensuring alignment with objectives, targets, and relevant external factors? Option A. Implement the LED lighting upgrade and compressed air optimization immediately due to their clear energy savings potential, deferring the VFD implementation and regulatory compliance integration until a later review cycle to avoid complicating the initial action plan. Option B. Prioritize initiatives based on the highest projected energy savings. Integrate the regulatory compliance into the plan by modifying ventilation system operation. Assign responsibilities, set timelines, and establish a system for monitoring progress against the NPI and the overall objective. Option C. Develop separate action plans for each identified initiative, ensuring each plan includes specific actions, resources, responsibilities, and timelines, but do not explicitly link the regulatory compliance to the energy objectives or the NPI. Option D. Focus solely on the technical feasibility and cost-effectiveness of each energy-saving initiative, disregarding the new regulation as it pertains to emissions rather than direct energy consumption, and then document the selected actions without detailed resource allocation. The correct answer is B. Prioritize initiatives based on the highest projected energy savings. Integrate the regulatory compliance into the plan by modifying ventilation system operation. Assign responsibilities, set timelines, and establish a system for monitoring progress against the NPI and the overall objective. Explanation. The development of action plans to achieve energy objectives and targets stipulated by ISO 50001, 2018 requires a systematic approach that integrates various elements. Clause 6.2. Energy objectives and planning to achieve them mandates the establishment of action plans. These plans must detail what will be done, what resources will be required, who will be responsible, when it will be completed, and how the results will be evaluated. Crucially, these action plans must consider the energy review, the energy baselines, the energy performance indicators, and the overall energy management system, NMS. The action plans should also incorporate relevant legal and other requirements that may influence energy performance. Furthermore, the process of developing these plans involves identifying opportunities for improving energy performance and selecting the most appropriate actions. This selection process often involves evaluating the technical feasibility, economic viability, and potential impact on energy performance, as well as considering the organization's operational context and strategic direction. The action plans are living documents, subject to review and revision as energy performance is monitored and evaluated, and as new opportunities or challenges arise. The intent is to ensure that the organization's efforts to improve energy performance are structured, measurable, and contribute directly to the established objectives and targets. This involves a clear linkage between strategic energy goals and the practical steps taken to realize them, ensuring accountability and progress tracking throughout the NMS lifecycle. Question 20. Consider a manufacturing facility that has established an energy baseline for its primary production line based on the previous fiscal year's operational data. During the current year, the facility has implemented a new automated quality control system that has significantly reduced the number of rejected products, leading to a 15% increase in the output of saleable goods from the same production line, with only a minor increase in overall operating hours. According to ISO 50001, 2018 Principles for Energy Baseline Adjustment, what is the most appropriate course of action for the energy management team regarding the established baseline? Option A. Maintain the original energy baseline without adjustment, as the core production process technology has not fundamentally changed, and focus solely on the impact of new energy-saving measures. Option B. Adjust the energy baseline to account for the increased output and reduced waste, ensuring the baseline accurately reflects the relationship between energy consumption and the new operational reality. Option C. Re-establish a completely new energy baseline from scratch, disregarding all previous data due to the significant change in production output and waste reduction. Option D. Adjust the energy baseline only if the total energy consumption for the production line has decreased. Otherwise, no adjustment is necessary regardless of output changes. The correct answer is B. Adjust the energy baseline to account for the increased output and reduced waste, ensuring the baseline accurately reflects the relationship between energy consumption and the new operational reality. Explanation. The establishment of an energy baseline is a foundational step in ISO 50001-2018, serving as a reference point for measuring energy performance improvements. Clause 6.2.2 Energy Review, and Clause 6.3 Energy Baselines and Energy Performance Indicators detail the requirements. An energy baseline should represent a specific period of energy consumption and relevant variables. When significant changes occur that affect energy consumption, the baseline may need adjustment to maintain its relevance and accuracy for performance monitoring. Such changes could include alterations to production processes, changes in operating hours, significant upgrades to energy-consuming equipment, or substantial shifts in the use of relevant variables, e.g., climate control setpoints, production output levels. The standard emphasizes that the baseline should be documented and its adjustment criteria defined. The purpose of adjustment is to ensure that energy performance indicators, NPI, accurately reflect the impact of implemented energy-saving measures, rather than being distorted by external factors or changes in operational parameters. An adjusted baseline allows for a more realistic assessment of whether the organization is achieving its energy objectives and targets. Question 21. A multinational manufacturing firm operating in multiple jurisdictions with varying environmental and energy regulations is reviewing its ISO 50001-2018 energy management system. The firm has identified a recent amendment to a national energy efficiency directive that mandates stricter reporting requirements for industrial energy consumption and introduces new incentives for adopting renewable energy sources. As the lead implementer, what is the most effective approach to ensure the organization remains compliant and leverages these changes for improved energy performance? Option A. Initiate a comprehensive review of all existing legal and other requirements, Assess the direct impact of the new directive on current energy uses, consumption, and efficiency, and update relevant operational procedures and NPIs accordingly, while exploring the applicability of new renewable energy incentives. Option B. Rely on the external environmental consultant to interpret the new directive and implement any necessary changes to the NMS documentation without direct internal involvement in the assessment phase. Option C. Focus solely on updating the energy performance indicators, NPI, to reflect the new reporting mandates and postpone the exploration of renewable energy incentives until a later review cycle. Option D. Conduct a one-time audit of the energy management system against the new directive and assume that any identified nonconformities will be addressed through routine corrective actions without a proactive process update. The correct answer is A. Initiate a comprehensive review of all existing legal and other requirements. Assess the direct impact of the new directive on current energy uses, consumption, and efficiency, and update relevant operational procedures and NPIs accordingly, while exploring the applicability of new renewable energy incentives. Explanation: the core of updating legal and other requirements within an ISO 50001-2018 Energy Management System, NMS, lies in establishing a systematic process that ensures ongoing compliance and integration with energy performance improvement. Clause 6. 1. 3 of ISO 50001-2018 mandates that an organization shall establish, implement, and maintain a process to identify and have access to the legal requirements and other requirements to which the organization subscribes that apply to its energy uses, consumption, and efficiency, including energy performance. It further states that the organization shall determine how these requirements apply to its energy uses, consumption, and efficiency, and shall take into account these requirements when establishing, implementing, and maintaining its NMS. The process for updating these requirements must be proactive, involving monitoring of legislative changes, regulatory updates, and industry best practices. This monitoring should be continuous, utilizing reliable sources such as government gazettes, official regulatory websites, industry associations, and specialized legal update services. Upon identification of a change, the process must include an assessment of its impact on the organization's energy performance, energy uses, consumption, and efficiency. This assessment will determine the necessary actions, which could range from updating operational procedures, modifying energy performance indicators, NPI, revising energy targets and objectives, or implementing new technologies. The updated information must then be communicated to relevant personnel and documented within the NMS. Therefore, a comprehensive process that includes continuous monitoring, impact assessment, and integration into the NMS is crucial for maintaining compliance and driving energy performance improvements. Question 22. An energy management team at a large manufacturing facility is tasked with updating their risk and opportunity register as part of their ISO 50001-2018 system review. They are considering various external and internal influences. Which of the following influences, if not proactively addressed, presents the most significant potential for negative impact on the facility's energy performance and compliance with future energy-related legislation? Option A. The development of a new, stricter national carbon emissions tax that directly impacts energy generation. Option B. The potential for a major supplier to experience a temporary disruption in their logistics. Option C. The introduction of a new voluntary industry best practice guideline for energy efficiency. Option D. A gradual increase in the price of a key raw material used in production. The correct answer is D. A gradual increase in the price of a key raw material used in production. Explanation: the fundamental principle behind identifying energy-related risks and opportunities within an ISO 50001-2018 framework is to systematically consider factors that could positively or negatively impact the organization's energy performance, energy consumption, and energy use. Clause 6. 1. 2 of the standard mandates this process. When evaluating potential risks, a lead implementer must look beyond immediate operational issues to broader influences. These include regulatory changes that might impose new energy efficiency standards or carbon pricing mechanisms, technological advancements that could offer more efficient equipment or processes, market fluctuations in energy prices affecting operational costs, and even geopolitical events that could disrupt energy supply chains or opportunities. The focus shifts to leveraging these same factors for improvement, such as adopting new technologies to reduce consumption, capitalizing on government incentives for renewable energy, or optimizing processes to benefit from lower energy market prices. A comprehensive approach involves engaging relevant stakeholders, analyzing historical energy data, and considering the entire life cycle of energy-consuming equipment and processes. The goal is to integrate risk and opportunity management into the core of the energy management system, ensuring proactive measures are taken to enhance energy performance and achieve strategic energy objectives. The question probes the understanding of what constitutes a primary driver for considering these factors, emphasizing the proactive and strategic nature of risk and opportunity identification, as stipulated by the standard. Question 23. Consider a large, multi-site industrial conglomerate that has recently certified its primary manufacturing plant to ISO 50001-2018. The top management representative designated to oversee the energy management system, NMS, is seeking to visibly and effectively demonstrate their leadership and commitment across the organization. Which of the following actions would most powerfully convey this commitment to all relevant stakeholders, including employees, operational managers, and the board of directors? Option A. Actively participating in the establishment and periodic review of key energy performance indicators, NPI, and the energy review process, ensuring alignment with strategic business objectives. Option B. Securing and approving a specific annual budget allocation for energy efficiency projects and NMS maintenance activities. Option C. Consistently attending all scheduled energy management system review meetings and providing feedback on documented minutes. Option D. Appointing a dedicated energy management team with clear responsibilities and delegating the day-to-day operational aspects of the NMS to this team. The correct answer is A. Actively participating in the establishment and periodic review of key energy performance indicators, NPI, and the energy review process, ensuring alignment with strategic business objectives. Explanation. The question asks about the most effective method for a top management representative to demonstrate leadership and commitment to the energy management system, NMS, in a large manufacturing facility. Considering the ISO 50001-2018 standard, ISO 50001, Clause 5. 1. Leadership and commitment emphasizes that top management shall demonstrate leadership and commitment with respect to the NMS. This involves taking accountability for the effectiveness of the NMS, ensuring the energy policy is established and aligned with the organization's strategic direction, integrating NMS requirements into business processes, providing the necessary resources, and communicating the importance of effective energy management. While all options involve management action, the most impactful demonstration of commitment, especially in a large facility with diverse operations, is the active participation in defining and reviewing energy performance indicators, NPI, and the energy review process. This directly links energy management to operational performance and strategic objectives, showcasing a deep understanding and commitment beyond mere delegation. Establishing an energy management team is a crucial step, but the representative's direct involvement in the core analytical and strategic aspects of energy performance is a stronger indicator of leadership. Allocating a budget, while necessary, is a resource provision, not necessarily a direct demonstration of leadership in the NMS itself. Regularly attending NMS meetings shows engagement, but can be passive compared to actively shaping the strategic direction through NPIs and reviews. Therefore, the most robust demonstration of leadership and commitment is through active involvement in the strategic direction and performance evaluation of the NMS, specifically by participating in the establishment and review of NPIs and the energy review. Question 24. Consider a manufacturing facility that has implemented a comprehensive energy management system aligned with ISO 50001-2018. The organization is exploring the potential benefits of upgrading its primary boiler system to a more energy-efficient model. To support this investment decision, what is the most appropriate application of simulation and modeling tools in this context, as per the principles outlined in ISO 50001-2018 guidance? Option A. To validate the accuracy of the organization's energy performance indicators, NPI, by cross-referencing them with simulated output from the existing boiler system. Option B. to forecast the probable reduction in fuel consumption and associated operational costs under various load conditions for the new boiler system, enabling a comparative analysis against the current system. Option C, to generate a real-time dashboard displaying the immediate energy savings achieved by the new boiler system once it is installed and operational. Option D, to retroactively analyze historical energy consumption data to identify any past operational inefficiencies that may have occurred during the previous fiscal year. The correct answer is B, to forecast the probable reduction in fuel consumption and associated operational costs under various load conditions for the new boiler system, enabling a comparative analysis against the current system. Explanation: ISO 50001, 2018, in its Annex A guidance, suggests the use of simulation and modeling tools for evaluating energy performance improvements. These tools are not about predicting absolute future energy consumption without context, nor are they solely for identifying past anomalies. Instead, their primary utility lies in the predictive capacity to assess the potential impact of proposed operational changes or technological upgrades on an organization's energy performance. This involves creating virtual representations of energy-consuming processes and systems, allowing for the testing of different scenarios and interventions without affecting the actual operations. The goal is to forecast the likely energy savings or impacts of these changes, thereby informing decision-making for energy projects. This predictive capability is crucial for prioritizing investments and ensuring that planned actions align with the organization's energy objectives and targets. The process involves calibrating the model with historical data to ensure its accuracy before using it for forecasting future scenarios. The output of these simulations helps in understanding the sensitivity of energy consumption to various factors and the effectiveness of different energy management strategies. Question 25. Consider a manufacturing firm, Stellar Components, that has outsourced the complete maintenance and operational management of its primary compressed air system to an external specialist company. Stellar Components' ISO 50001, 2018 certified energy management system includes ambitious targets for reducing specific energy consumption in its production processes. What is the most critical consideration for Stellar Components to ensure its outsourced compressed air system management aligns with its ISO 50001, 2018 requirements and energy performance objectives? Option A, establishing a comprehensive service level agreement that explicitly details energy performance indicators, monitoring protocols, reporting frequencies, and contractual obligations for energy efficiency improvements within the outsourced system. Option B, conducting a detailed energy audit of the external service provider's facilities to verify their internal energy management practices and certifications. Option C, delegating the entire responsibility for energy performance monitoring and improvement of the compressed air system solely to the external service provider, assuming their expertise guarantees compliance. Option D, requiring the external service provider to submit quarterly reports on general operational uptime and maintenance activities without specific energy consumption data. The correct answer is A, establishing a comprehensive service level agreement that explicitly details energy performance indicators, monitoring protocols, reporting frequencies, and contractual obligations for energy efficiency improvements within the outsourced system. Explanation: the core of managing outsourced processes within an ISO 50001, 2018 framework, particularly concerning energy performance, lies in ensuring that the outsourced activity contributes to the organization's overall energy objectives and targets. Clause 4.3 of ISO 50001, 2018 requires an organization to determine the scope of its energy management system and identify processes needed for the EMS, including those that are outsourced. Clause 8.1, Operational Planning and Control, mandates that the organization shall plan, implement, and control the processes needed to meet its energy performance requirements, and to implement the actions identified in its energy review and other EMS planning activities. When a significant energy-consuming process, such as the operation of a large-scale industrial chiller system, is outsourced to a third-party service provider, the organization retains ultimate responsibility for the energy performance of that process, as it falls within the scope of the EMS. Therefore, the organization must ensure that the agreement with the service provider clearly defines energy performance criteria, monitoring and measurement requirements, and reporting mechanisms that align with the organization's own energy objectives and legal requirements related to energy efficiency. This includes specifying operational parameters, maintenance schedules that impact energy use, and how energy performance will be evaluated and reported back to the organization. The agreement should also outline responsibilities for identifying and implementing energy-saving opportunities within the outsourced process. The organization must then monitor the performance of the outsourced process against these defined criteria to ensure it is contributing positively to the overall energy management system. Question 26. An organization implementing an ISO 50001-2018 compliant energy management system is exploring the integration of on-site solar photovoltaic generation. Considering the standard's emphasis on continual improvement of energy performance and the management of energy sources, which of the following actions best aligns with the principles of ISO 50001-2018 for evaluating the impact of this new renewable energy source? Option A. Primarily focus on the capital expenditure and return on investment of the solar PV system, treating its energy contribution as a secondary benefit rather than a core element of energy performance improvement. Option B. Conduct a one-time assessment of the solar PV system's capacity and then incorporate its output into the organization's overall energy balance without updating the established NPIs or targets. Option C. Revise the organization's energy performance indicators, NPI, to include metrics that quantify the proportion of energy supplied by the solar PV system and its impact on overall energy consumption from the grid. Option D. Establish a separate, standalone energy management system specifically for the solar PV generation to track its operational efficiency independently from the main facility's energy performance. Correct answer is C. Revise the organization's energy performance indicators, NPI, to include metrics that quantify the proportion of energy supplied by the solar PV system and its impact on overall energy consumption from the grid. Explanation. The primary objective when integrating renewable energy sources into an energy management system, NMS, under ISO 50001-2018 is to improve energy performance. This involves not only reducing overall energy consumption, but also increasing the proportion of energy derived from renewable sources. ISO 50001-2018 Clause 6. 2. Concerning energy review, specifically requires organizations to identify significant energy uses and other relevant variables, which includes the sources of energy. Clause 6. 3. Establishing energy baselines, energy performance indicators, NPI, and energy targets necessitates considering all energy sources, including renewables, when setting performance metrics and objectives. Therefore, the most appropriate approach to assess the contribution of renewable energy to the NMS is to integrate it into the existing energy performance indicators and targets, ensuring that improvements in renewable energy utilization directly contribute to the overall energy performance objectives and the organization's commitment to sustainability. This integration allows for a holistic view of energy performance, encompassing both efficiency gains and the shift towards cleaner energy sources, aligning with the standard's emphasis on continual improvement of energy performance. The focus remains on measurable improvement in energy performance, which is the core of the standard. Question 27. When formulating energy management action plans as per ISO 50001-2018, what is the most critical factor to ensure their effective integration with the organization's broader strategic and operational framework, considering the requirement to comply with relevant legal and other requirements? Option A. Ensuring that each action plan is directly linked to a specific legal or regulatory mandate and demonstrably contributes to achieving the organization's overall strategic business objectives. Option B. Developing detailed technical specifications for new energy-efficient technologies without first assessing their operational feasibility or impact on existing business processes. Option C. Documenting all energy-consuming equipment and their operational parameters without establishing clear action steps or responsibilities for improvement. Option D. Prioritizing actions solely based on the highest potential for immediate energy cost reduction, irrespective of their alignment with strategic goals or regulatory compliance. The correct answer is A. Ensuring that each action plan is directly linked to a specific legal or regulatory mandate and demonstrably contributes to achieving the organization's overall strategic business objectives. Explanation: the development of energy management action plans under ISO 50001-2018 requires a systematic approach that integrates energy performance improvement with operational and business objectives. Clause 6.2. Energy review, and Clause 6.3. Energy baselines, energy performance indicators and targets, and energy management objectives are foundational. The action plans, often referred to as the planned phase of the PDCA cycle, must be informed by the energy review and the establishment of baselines and targets. A crucial aspect is ensuring that the identified energy-saving opportunities are prioritized based on feasibility, cost-effectiveness, and potential impact on overall energy performance. The action plans should clearly define specific actions, assign responsibilities, establish timelines, and allocate necessary resources. Furthermore, these plans must align with the organization's strategic direction and comply with relevant legal and other requirements, such as national energy efficiency regulations or local environmental mandates that might influence operational practices or investment decisions in energy-consuming equipment. The integration of these elements ensures that the action plans are not merely technical documents, but are embedded within the organization's management system and contribute to achieving the defined energy management objectives and improving energy performance. The focus is on creating actionable, measurable, achievable, relevant, and time-bound, SMART initiatives that drive continuous improvement. Question 28. An organization implementing an ISO 50001-2018 energy management system is reviewing its energy performance for the past fiscal year. They have established energy performance indicators, NPI, and corresponding baselines for their primary production line, which manufactures custom ceramic tiles. During this period, the organization upgraded its kilns to a more energy-efficient model and also experienced a significant, but temporary, increase in production volume due to a large export order, which was not a planned operational change. Which of the following approaches would be most effective for the organization to accurately evaluate its energy performance in this context, considering the requirements of ISO 50001-2018? Option A. Compare the total energy consumption of the past year against the established baseline, adjusting for the overall increase in production volume and acknowledging the impact of the kiln upgrade without quantifying its specific contribution. Option B. Analyze the energy consumption data by segmenting it into periods before and after the kiln upgrade, and then comparing these segments to the baseline while ignoring the impact of the increased production volume. Option C. Focus solely on the specific energy consumption, SEC, per unit of ceramic tile produced, comparing this year's SEC to the baseline SEC and disregarding any other operational or equipment changes. Option D. Calculate the projected energy savings from the kiln upgrade based on manufacturer specifications and subtract this from the total energy consumed. Then compare the result to the baseline. The correct answer is A. Compare the total energy consumption of the past year against the established baseline, adjusting for the overall increase in production volume and acknowledging the impact of the kiln upgrade without quantifying its specific contribution. Explanation: the core of evaluating energy performance in ISO 50001-2018 lies in establishing and utilizing relevant performance indicators, NPI, and baselines. An NPI is a quantitative value derived from a set of variables that provides a means for the organization to determine its energy performance. The baseline is a reference point against which energy performance can be assessed. Clause 6.4 of ISO 50001-2018 mandates that organizations establish the necessary variables, including energy consumption, relevant activity data, and where applicable, statistical methods, to monitor and measure energy performance. The effectiveness of the energy management system, NMS, is directly tied to the ability to accurately track changes in energy consumption relative to changes in the relevant activity data. When evaluating performance, it is crucial to consider the impact of both planned and unplanned changes. Planned changes, such as the introduction of new energy-efficient equipment or modifications to operational processes, should be analyzed to determine their impact on the established NPIs and baselines. Unplanned changes, like variations in production schedules or external factors affecting energy availability, also need to be accounted for to ensure a fair and accurate assessment of the NMS's contribution to improved energy performance. The process involves comparing current energy performance against the established baseline, considering the influence of relevant variables and any changes that have occurred. This comparison allows for the identification of trends, deviations, and opportunities for further improvement. Therefore, the most effective approach to evaluating energy performance is one that rigorously compares current consumption against a baseline, accounting for all significant influencing variables and changes. Question 29. When a manufacturing firm aiming to enhance its ISO 50001-2018 compliant energy management system is evaluating the procurement of new industrial pumps, what primary criterion should guide the selection process to most effectively align with the standard's intent for improving energy performance through acquisition? Option A. Selecting pumps based on the manufacturer's warranty period and after-sales service availability. Option B. Evaluating pumps based on their projected life cycle energy consumption and associated operational costs. Option C. Choosing pumps that offer the highest flow rate capacity, regardless of energy input efficiency. Option D. Prioritizing the pumps with the lowest initial purchase price, assuming all meet minimum operational requirements. Correct answer is D. Prioritizing the pumps with the lowest initial purchase price, assuming all meet minimum operational requirements. Explanation: the core principle of integrating energy performance into procurement, as mandated by ISO 50001-2018, is to ensure that energy-consuming products, equipment, and services are selected based on their life cycle energy performance, not solely on initial purchase price. Clause 6.1.3 Energy Performance Improvement, and Clause 8.1 Operational Planning and Control implicitly support this by requiring consideration of energy performance in the design and acquisition of energy-consuming items. Specifically, the standard encourages the establishment of criteria for energy performance when acquiring energy services and equipment. This means that when a company is looking to purchase new machinery, for instance, the energy efficiency of that machinery over its expected operational lifespan, including energy consumed during use, maintenance, and disposal, should be a key factor in the decision-making process. This life cycle perspective allows for informed choices that contribute to overall energy savings and the achievement of energy objectives. Other considerations, such as operational costs beyond energy, environmental impact unrelated to energy consumption, or the immediate availability of the product, while important in general procurement, do not directly address the ISO 50001 requirement for prioritizing energy performance in the acquisition of energy-related assets. Question 30. A manufacturing facility, Etherid Dynamics, is undergoing its first ISO 50001-2018 certification audit. During the audit, the auditor questions the clarity and execution of energy-related tasks assigned to various departments. Specifically, the auditor notes that while the energy policy outlines a commitment to reducing energy consumption in lighting by 10% within 2 years, the specific tasks for facility management and the R&D department to achieve this reduction lack defined completion dates and clear ownership beyond departmental heads. Which of the following best reflects the critical deficiency in Etherid Dynamics NMS concerning the assignment of responsibilities and timelines as per ISO 50001-2018? Option A. Insufficient communication of the energy policy to all employees, leading to a general lack of awareness regarding energy-saving targets. Option B. The audit finding that the 10% lighting reduction target itself is not sufficiently ambitious to demonstrate significant energy performance improvement. Option C. Over-reliance on departmental heads to unilaterally define and manage all energy-related responsibilities without formal documentation or review. Option D. Failure to establish specific, measurable, achievable, relevant, and time-bound, SMART subtasks with assigned individuals and deadlines for departmental contributions to overarching energy objectives. The correct answer is D. Failure to establish specific, measurable, achievable, relevant, and time-bound, SMART subtasks with assigned individuals and deadlines for departmental contributions to overarching energy objectives. Explanation: the core of assigning responsibilities and timelines within an ISO 50001-2018 energy management system, NMS, lies in ensuring that individuals understand their roles and that actions are completed within defined periods to support the continuous improvement of energy performance. Clause 5.3 Organizational roles, responsibilities, and authorities mandates that top management shall ensure that responsibilities and authorities for relevant roles are assigned, communicated, and understood within the organization. This involves not only identifying who is responsible for specific energy-related tasks, e.g., data collection, performance monitoring, implementation of energy-saving measures, but also establishing clear deadlines for these tasks. Effective assignment considers the competence of individuals, their existing workloads, and the criticality of the task to achieving energy objectives and targets. Timelines should be realistic, measurable, achievable, relevant, and time-bound. SMART, aligning with the overall energy policy and strategic direction. The integration of these responsibilities and timelines into daily operations and performance reviews is crucial for the system's effectiveness. This proactive approach prevents delays, ensures accountability, and facilitates the systematic tracking of progress towards energy performance improvements, a fundamental requirement of the standard. The lead implementer's role is to facilitate this process, ensuring that the organizational structure and communication channels adequately support the NMS.